one and all. The subject name is compiler design. In this subject, we are going to discuss some of the definitions and terminologies in the type checking and the runtime environment. What are the different terms? The description in the case of type checking and runtime environment. First, define type checking. What is meant by type checking? So here, the type checking, it is a process of verifying the errors in the given program. That is either by the compiler or during the execution of the program. Sometimes the errors are to be the compilation point of view, C compiler, which is used in that program execution part. So that, and while running the program, some of the errors may occur. So that is the different types, whether it is done declaration parts like this, it verifies each of the phase of the compilation point. Now, what is static checking and what is meant by dynamic checking? A static checking is nothing but this is type checking, verifying the errors. Static checking is nothing but verifying the syntax checks performed by the parser, and the semantic checks, flow control checks, and the uniqueness name related checks. So here, when we are going to declare some types, variable names, arrays, pointers, any declaration points, maybe we may forget some of the types in that expression value. So assignment declarations are verifying whether it is, suppose for example, A is which we are using in the program, but A may be declared as of type int, but the value of A can be attained during the execution of the program, may results to some floating other type notations. Then that is to be described clearly what is the type. So that is strictly verified this semantics, syntax checks and semantic checks. These are called as type checking, static checking, type checking. Flow of control checking is nothing but when programmatic statements are declared inside an if condition or switch statement. So some of the cases we can apply a break statement. If break is encountered, then it can be exit from that one. So that is valid only for loop, while loop and switch case statement. For all the cases, this is not able. So that's why it will verify whether that control flow is allowing to continue break statement, continue statement where it is declared unnecessary checking, unnecessary putting that one. Those things are to be verified. And another one is uniqueness checks. Here the check is to be verified uniquely. That means A is declared one time. So if there is a chance of declaring A once again in the part of the program, in anywhere else with redeclaration, that means it declaring several times overlap occurs. So that's why we have to verify whether A is declared uniquely or not. And the name related checks are also verified. It verifies what is the name that is assigned for this. Suppose if you say go to label 1. So where the label 1 it is declared. So that instruction goes to the compilation part where the statement where the label 1 is to be placed for the corresponding statement that is to be executed. Suppose instead of label 1, if you define any other name like label 2 or which is not present, then it doesn't execute the corresponding. That means there is a name related issue in this case. So that is to be verified in this type of static checking. And another one is dynamic type checking. Here, in case of dynamic type checking, it is the process of verifying the type safety of the program at runtime. Some of the dynamic typed languages include Groovy, JavaScript, Lisp, Objective-C, PHP, Prolog, Python, Ruby, Smalltalk. That means it verifies the types which are declared safety of that program at dynamically at runtime. So if you are going to allocate some amount of memory at the beginning of the declaration of the program, and after duration of time, if that is used, say for example, we have 50 is to be declared, is to be assigned, is to be at the beginning we declared, but some of the elements which are used we have 10 and remaining elements are not consumed. So here, instead of wasting the space, the accommodation of these 10 elements can be suited as per the requirements of the program at runtime. At runtime, it verifies what is the actual requirements of the elements of that in that program. Then remaining can be accommodated. Remaining, if not available, then it is to be. So in that case, it verifies the checking of that program, dynamic checking. And what is meant by type expression? A type expression are built from the basic types and constructors only. So here it is an equivalence. Suppose if the equivalence between two type expression structurally equivalent, that means they have same basic type, or applying the same constructor are structurally equivalent, are said to be structurally equivalent. So what is the types that are defined for a particular basic types, in the sense int, float, void? These are called as basic types, and the pointer type, constructor type, any other reference type may also be allowed. But we can say that whenever the two type expressions which are equivalent structurally, in the sense they have the basic type or some constructor type structurally equivalent. The define function overloading. We already know this is the familiar concept which is used in the Java program, in object-oriented programming concept. That means we are going to create several functions with the same name and a different implementation. That means a constructor one is defined. Suppose, uh, add is the function name, and this function name with parameters a comma b if you define, then we can also write another function add with parameter int a, and we can also write another function int a b c. So like not only int argument. So here we are going to implement function name is same, so we can call add function, but implementations of the different. Implementation wise, it is different. Different implementation, same function. So here, same function name with different arguments. That is, here we are going to apply. Here, what is meant by structural equivalence of type expression? Previously, you have seen the structural equivalence of type expression. Two structural equivalence once they are with the same basic type notation, or they also have constructor type notation. Basic type or constructor type notation. Basic type include that is, we know that integer, float, character, double, etc. Void, etc. These are all called as basic type. And constructor type, which I have seen previously, add is a function with one constructor name. And these equivalents is to be structurally verified which have the same basic type or from that. So it's constructed to the same equivalent expression. What are the two uses of type checking? So generally this it depends on the language type checker. The first one is application of function with the number of arguments, and second one is use of undeclared variables in expression. Suppose if you are going to call the function with add function with say we are going to define add function, but we are going if the parameters applied in this one 10, 20, and you define add function with parameters only 10, only x, only one parameter, but when you call with this one two parameters, that means without overloading concept. So at this case, we are going to pass actual number of expected arguments. How many? Here 10, 20. That means two arguments it is expecting. But while calling this function, what happens here? Only one argument is available. So you cannot pass the second argument value. So this argument value cannot. That means there is a mismatch. There is a mismatch in the number of arguments with the parameters while calling the function. So that function mapping name is mapped, but parameters are not mapped. So in this case, the type checking is to be used to verify whether the number of arguments actually passed or not. And the second important one is and use of undeclared variables in the expression. So here suppose a equal to b plus c minus d. If you declare a, b, c, so int a comma b comma c. So what about d? Here if you do not declare, then this comes under undeclared variables. The variable d is undeclared in the expression. So such type of process can be verified if you apply the type checking process. So it is helpful to verify the number of arguments correctly passed in the arguments while calling the function, and it also verifies whether all the variables inside the expression is correctly declared or not. If any undeclared variables are there, then type checking process is to be used and implement this. What is the flow of control checks? Here we know that a construct can be used, and this construct transfer from one to another. That means at the beginning of the function, it enters into the corresponding line of statement. So after the execution of some, that means at the end of the function, the flow of control is completed. That means it leaves the construct. Now what is meant by type systems? Here type system is nothing but what some of the rules are to be assigned to the type expression, to the syntactic constructors of the program. Syntactic constructs of the program, we are going to assign some rules, type expression. So that is called as type systems. What is strongly typed languages? Here strongly typed languages are nothing but the type of language based on how it can be used. What is the rules? Type inference rules are used in order to determine the type of a language, the corresponding answer based on how it is. What is type inference? A dynamically typed language in which some of the construct of a language can only be typed at runtime, like Perl, Python, Lisp, and dynamically typed language are dynamically typed. What is dynamically typed languages? A dynamically typed language is a language in which some of the constructs of the language can only typed at runtime. Example, Perl, Python, and Lisp are dynamically. That means suppose in the case of Python, whenever we are no need not declare at the beginning of the program. So as whenever we required, as we wish, as per the requirements, we can declare that variable and you can use it. So such type of facilities are available in case of dynamically typed languages. So these are the constructs. And what is operator overloading? Previously I have seen function overloading. Now operator overloading indicates that it just specifies what are the operators used in the programming for implementation. So generally we are implementing the user defined types, and based on the types of arguments that is to be passed. Activation trees. What is activation tree? Here activation tree is nothing but generally a program first initially consists of some procedures. Procedure means it is a function which has some declaration followed by the, that is the form, and then procedure name, declaration name, and body of that procedure. That means in the declaration, declaring the procedure with procedure name followed by body of the procedure. Then execution of the program is referred as activation of the procedure. That means whenever the control comes to that particular part of the function, it enters into that body of the statement, and then after completion of the block of statements, it leaves the control. So this is part of the activation of that procedure. What are the two parts of activation trees? Here each node represents the activation of a procedure. Root node shows the activation of the main function. The node for procedure X is the parent node of the procedure Y only if the control flows from procedure X to procedure Y. That means here node activation node, there will be a root node at the beginning of the structure, and the node having some X is the node and Y is the parent. X is the parent and Y is the parent node for the corresponding procedure. So if the control flow is moving from one procedure to another procedure, then there is a activation tree takes place. Suppose, for example, if you are applying quicksort of m comma n, 10 comma 5. Now this activation leads to the supports of again quicksort of 5 comma 2 like this. So sub procedures. So this is the node activation node at the root. Now the support once again the node procedure is to be executed. So this is the result which is passed to the parent node for the procedure. And the control flow is moving from procedure X to procedure Y. And finally the result can be obtained. And what is meant by control stack? A control stack or runtime stack is used to keep track of the live procedure activation. So here, whenever previously we defined that activation procedure, activation tree is to be generated with the corresponding each time calls. So that is to be maintained in a stack mechanism that is called as runtime stack or control stack. This is called as runtime or control stack, where the procedure is to be started, then activation of the procedure takes place, then the execution, that is the procedure whose execution are not completed. Procedure name is, whenever we call, is pushed onto the stack. Initially, what is the procedure? Suppose if the add procedure, if you complete start activation, that it immediately send to the stack contents of the stack contents of that particular scenario, that is table, and then activation begins immediately, and whenever the procedure completes, then it returns. That means activation ends. That means it stops the procedure, activation ends. So activation begins whenever procedure calls, and the activation ends whenever procedure leaves. What is activation record? So whenever we have started the, whenever we created an activation of the particular procedure, whenever we call a function, in that case it identifies some of the fields for the purpose of maintaining in the hash table notation or stack contents. So this record is to be maintained. Each procedure has some activation record. This activation records has some fields such as local variables, temporary values, mission status, access link, control ring, and return value. That means here we know that whenever a procedure begins, some of the variables which are declared inside that, so those are comes under local variables. And for temporary for assumptions, for some middle intermediate calculations, we are going to use temporary values also. And what is the mission status code that is to be used? Access link for that one, control link, and whenever function completes, it returns some value. So these control access link are to be used whenever the activation starts and within this one. Okay. Next, list the various storage allocation strategies. We know that the static storage allocation, stack storage allocation, and third one is heap storage allocation. These are the three allocations. What is the static storage allocation? Static storage means only at we can create a memory at compile time. That means it is the area which is called as static area and memory is created only once. Whereas stack storage allocation means storage is organized as a stack and activation records are to be pushed onto the stack whenever activation begins and activation ends. It is to be popped from that stack. Locals are contained in the activation record so that they are bound to fresh storage in the activation record. Each activation, whenever you complete that corresponding variables, then this will be eliminated, the procedure ends, and the next procedure which is running, which is came for execution or to the stack, they can use this storage, fresh storage, and once again do the completion of this. And what is meant by heap storage allocation? Heap storage allocation, it is used dynamically to allocate memory to the variables and claim it back the variables no more required here. Memory allocations and deallocations can be done at any time and the place depending on the requirement of the user. Here the variables can claim back when the variables are not required. That means previous storage allocations completed and their values does not exist. So by means of garbage collection or we can quit these variables, and these variables can be once again you can use it in any other function. They reallocate or deallocate after deallocation at any time, and they may use the allocation and deallocation of the process further as for the requirements of the user program. Okay. Next, what is a symbol table? Here, symbol table means it is an important data structure which is used for the purpose of storing the information of various entries such as variable names, function names, object classes, interface. Each time, whenever you call the function or activations begins with variable record names, all these to be recorded inside a symbol table. So we can resolve the multiple reference name. That means if you declare a variable, whether it is already declared, based on that it verifies, and then by the use of the method lookup method it can verify. List the various implementation of a symbol table. Generally we can implement by using a linear list, binary search, tree and hash table. These are the ways to implement symbol table. What are the operations which we performed on the symbol? So because symbol table it contains several number of entries like serial number 1, 2, 3, 4. Like first entry is variable name, the function name or I equal to 10. Someday we are going to write several entries in the symbol table notation. So these entries are to be recorded. So suppose if you want to perform some operation, I want to insert a variable name. So I can use a method name that is called as insert method. I want to verify whether the variable I declared exists in the entry or not. By using the lookup method, I can go for. So what is lookup operation? Here you want to search for a particular name, whether it is available in the symbol table or not. And if the symbol suppose exists in the symbol table, what is the scope, what is the name that is to be used, and what is the symbol that is to be initialized, and how many times it is declared. So those things are to be verified by applying this lookup operation with the symbol table. And what is scope management? Here scope management is nothing but there are two types of symbol table. One is global, another one is um, accessed global symbol table, which can be accessed by all the procedure, and the scope symbol table. Here this is actually within the scope only. So throughout all, that is called as global symbol table, anywhere accessing the procedures. What is static storage allocation and difference? Previously I have seen static versus dynamic storage allocations. Where static storage allocation, memory is allocated before the execution of the program and implemented using a stack mechanism. Whereas dynamic allocations, we can have the choice of resize it after allocation also. That means you can have stretching of memory at runtime and implementation of using heap mechanism and dynamically expand and shrink, shrinking mechanism as per the necessary requirements. What is control link and access link? Here, control link is points to the activation record of the caller. Access link is used to refer to the non-local data held in other records. So, this is about definition terminology with this type checking and runtime environment. Thank you. We'll come up with one more definition terminology with the new type. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.